Hello, good morning, dear students. Today, I am going to explain you the time complexity of an algorithm. Okay, how to calculate the time complexity of a given program or of a given algorithm. Okay, so as you know that this time complexity is said to be is defined as the minimum amount of time needed by any program to complete its task. So yesterday also we have discussed about the time complexity, the definition we have seen, and what are the different how you are going to, or what are the factors on which this time complexity is based, the factors on which this complexity is determined, like that. Okay, so I told you yesterday that a program, when going for an execution, it has to undergo certain conversions, isn't it? A program, first, the initial part of that program means what? Initial stage of the development of a program is the writing of an algorithm. That algorithm is converted into programming code using some programming language. And after that, you are going to save that program in your computer's memory so that it has to be loaded, it has to be loaded into the computer memory for getting executed. So you are going to save that program into computer's memory, and then you are going for the compilation process. Why you are going for the compilation process? You know the reason of that, because you want to find the errors, what all are coming inside that logical part, or syntactic errors, like that. All that errors have to be determined before the execution starts. Okay, so for that purpose you have to complete the compilation process successfully. After the compilation process, the next step was the execution or running of the program. Execution or running of the original program. Okay, so this is how the different stages of a program happens. And after the completion of the execution, what you are getting? You are getting the output of your program. Okay, output. Okay, so you have provided some input to the program, and after that you are getting the output. So this is all what we are, this is all what about the conversions. Okay. Now, for determining the time complexity, I told you we have to consider these two terms, the compile time, and the next one was the run or execution time. Okay, run or execution time. Clear? So yesterday we talked about what is this compile time and what is this run time, and to which factor this time complexity depends, whether it is depending upon the compile time of the program or whether it is depending upon the execution time of the program. So at the end of the yesterday's class, we came to the conclusion that for two different programs, for the same program, for two different times of execution, the compile time remains the same, but the execution time may vary because it depends upon the input value provided to that program. Okay, so hope you understood that. So for the same program, when this same program is executed number of times with different values of inputs, there is a chance that the execution time may differ. If you are always providing same number of inputs, it will not give you the execution time, difference in execution time. But if you are providing the program with different inputs, different lengths of inputs, okay, different number of inputs, then there is 100% chance of the difference of the execution time. But there still the compile time remains same for that program. So we also came to the conclusion that when once a program is compiled, it is not necessary to recompile the same program for its every execution. Okay, so these are the two things we discussed yesterday. Okay, so researches are going on, and after a lot of researchers has completed, we came to the conclusion that we are only focusing on to the runtime or execution time of a program. Okay, so when you are writing a program, you know that this program consists of what are the things if this is consisting? It consists of a lot of statements. It consists of lot of statements. What these statements means, all these statements, different types of statements are there, isn't it? Some statements you call it as conditional statement, some statement you call it as an assignment statement, okay, some statement you call it as a beginning and end, means it is the start, it is a starting of that program, it gives the end of the program, like that. So these are the types of statements are there. Declarative statement is there, assignment statement is there, initialization statement is there, decision making statements are there, okay, looping statements are there. So different types of statements are there, isn't it? So statement in a program means every statement is going to perform some action. So every statement, whatever statement is present in your program, it is going to perform some action. Every statement in a program is going to perform some action. Okay, so and different types of statements are there. So do you think that and do you know, and different types of statements are there, different types of statements are there in a program, okay, such as the logical statement, decision making statement, assignment statement, declarative statement, looping statements, like that. Okay, hope you are getting my point. So I want to do say that, do you think that, my question is, do you think that all these statements, when gets executed, all these statement will take the same amount of time? Do you think that all statements that are present in a program require same amount of time for its execution? This is my question. Okay, so so you understand now, that means that this statement is going to perform some action. So whenever this statement is executed, you know how the execution of the program happens. The statements are starting from top, then to the bottom, top to bottom, okay, and execution also starts from top of the statement, top of the program, until it reaches the end of the program, isn't it? Down, top to down, that approach is used. Okay, first statement is executed first, then second, like that. The top to bottom approach is used for the execution. So each execution of a statement requires some time, isn't it? Each execution of a statement requires some time, some amount of time, isn't it? Whatever statement is present in that program, if you are going to execute a simple, suppose you are using what a C program, you are using C program, and the first initialization statement, you know that it is written like this, isn't it? Int and a equals to 3. This is the first statement in C. This is what, this is a declaring, it is a, first you can write like this, int a, it is declaring a variable then with the name a, and the type of the data type of that variable is int, and the second statement is a equals to 3. So these are two statements, isn't it? These are two different types of statements, and the first statement we call it as a declarative statement. We call it as a declarative statements. It is declaring a variable with a type. And second statement is what? It is an assignment statement, isn't it? It is assigning the value 3 to the variable a, assignment statement. So each of these statements are performing some action. Okay, so it requires some time. When int a is executed, it is initializing, it is declaring a variable a. That means what is happening here when int a is given in the C programming language, when that statement is executed, what is happening? That operating system is going to check the memory bank. Okay, memory bank, you know what is this memory bank? Memory bank means it contains all the free spaces available in the memory. So operating system will go and check the memory bank. whether it have some free spaces available so that it can take one space and as symbolize that space with the name A. Okay, and what is this variable is of integer type. So integer type require mainly 4 bytes of memory. Okay, so it will be taking 4 bytes of memory from the memory bank, and it will assign the name A to that memory spaces. Okay, so it is assigning A means for our means for our easiness, for the easiness of the programmer, we are thinking that that memory space is having the name A. Actually, it is having only memory addresses. It does not contain any alphabets there. Okay, symbolic names are not there. But for our theory purposes, we say that this memory space is symbolized with the name A. Okay, we will see that in details in later classes. Okay, so you have to just think that when int A is executed, what is happening? Operating system is going inside the memory bank. It will checks whether there are 4 bytes of memory spaces available or not. If 4 bytes of memory space are available, that 4 bytes of memory space are allocated to this variable A. Okay, and because why 4 bytes of memory for this A? Because it is of data type integer. Okay, so all these things are happening when that statement is executed. So some amount of time is spent there. Okay, even if that statement seems very short, int A, only 2 words are there, int A. So, but it takes some amount of time. Okay, it has completed some actions, and so it requires some time. Similarly, that second statement, A equal to 3. Okay, this second statement, A equal to 3. So this is a simple assignment statement. So what is happening here? The value 3 is assigned to the memory space symbolized by A. Okay, so that is what happens there. So it also requires some time. So what I'm trying to make you understand is that whatever statements are present in a program, all statements require some amount of time. Okay. So time complexity or execution time means what? All these statements executes one by one. So every statement is having some particular amount of time. So when you sum up all these statements execution time together, you will get the total amount of execution time for your program, isn't it? When you sum up all the individual statements execution time, you will get the total amount of execution time for your program. Is this correct or not? Yes, it is correct. Okay, so that means I will write here, when each statement's execution time is summed up, we will get the total amount of time spent for the completion of that program. That means we are getting the total execution time required by that program, required by that particular program. Okay, so when each statement's execution time is summed up, we will get the total amount of time spent for the completion of that program. That means we are getting the total execution time required by that particular program. Okay, so this is what time complexity is. Time complexity means you have to first calculate all the time required by each statement. Then you are going to sum up all the individual execution time of a statements, and then finally you will add all that statements. You will get the total execution time required by that program. Okay, hope this much is clear to all of you. So let us take one example, and I will show you how to calculate the time complexity of a program which contains looping statements. Okay, so let me erase this first. Okay, So suppose we have a program like that. I will be taking the same program that we discussed in our last classes. You know why I'm taking the same program? Because so that you can when you use the same program everywhere, you don't have to by heart the same program. Okay, one or two time when you use that, it will be already it will be easy for you to write it without by hearting it. Okay, so what was our program? Our program or the algorithm that we used in last classes are add. You are going to add the n number of elements present in an array. So you are initializing some variable sum is there, okay, and it is of a floating point sum. I'm not following the true structure of a program or an algorithm. I'm simply writing the logic, okay. So suppose there is a variable sum, since it is declared at 0.0, that means it is a floating type variable, okay. And there is a variable sum, it will hold the total sum of n numbers, okay. So for next, you are going to use a for loop. I am giving some gap because I will be writing something in between there, okay. So this is for loop, you are starting for loop, and here is a variable I equal to 0. You are providing I equal to 0. That means your array index is starting from 0, and I equal to 0, and I is less than n. Okay, I is less than n, and I plus plus. And here you are in the for loop. What is happening in the for loop? This sum is calculated. Sum is equals to sum plus a. You are tracing the array elements, so you will be providing the index here. So I is the variable which points to the index of that array, okay. And you are closing your for loop here, and then you are returning the sum value, return sum, and you are closing the main program, okay. So this is the program that is used here. What is happening? You are going to calculate the n sum of n numbers, okay, given in an array. So let us do and let us find the time complexity for this simple program, okay. So this is our program. So you see this, what is this A? It is an array. Okay, this is an array, our array, you know that. This is an array name, given array. And what is this N? This N is the total number of elements present in that array. Total number of elements present in that array. You know that total number of elements present in that array. You please don't bother about my handwriting here, okay. Total number of elements present in an array. So initially what is happening? Sum is initialized as 0. So you know what happens, you are now, so you can see that how many statements are there inside this algorithm. This sum equals to 0, this is the first statement. This for loop, this is the second statement. Inside the for loop, one statement is there, third statement. Outside the for loop, one statement is there, so this is a fourth statement. So how many statements are there? 4 statements are there. Now you are going to calculate the execution time of each of these 4 statements, okay. So that means you are going to calculate the, so this there is another term used here, okay. There is another term used here, and that is known as program steps. Program steps. What is it? It is the total number of, it is the total number of step counts in a program. In a program. So here another term is there, step count, okay. A new term is there, step count. So program steps means what? It is the total number of step counts in a program. And step count means what? It is the step count means step count is the number of time, a number of means a step count means an amount of time required by that program to complete its task. Amount of time required by that statement to complete its task. That is step count. Okay. So this step count is dealing with the statement, individual statement. And program steps means it is a total number of step counts of the whole program. Okay. So when you find the program step, you will get the time complexity. And step count means what? Individual statements execution time. Okay. So there is a difference. You can understand it. Now, this time complexity can be determined using two methods. Okay, time complexity can be determined using two methods. The first method is using a global variable known as count. Okay, and the initial value of this variable is 0. Okay, and the second method is using a tabular method. Okay, tabular method. I will explain each of I will be explaining each of these method one by one. So first I am going to explain how you are going to calculate the time complexity using the global variable known as count, and the initial value of this variable is 0. Okay, so let us see how you are going to calculate this time complexity using global variable. Okay, so suppose, so you know that this count variable has got initial value as 0. That means initially the count variable, I am writing count here. Okay, this is a count variable and I am writing count here, and this is the 0. The first value given to this count is 0. Okay, and whenever a statement gets executed, the count variable gets incremented by 1. Okay, so that means when the one statement completes its task, count variable incremented by 1. Okay, so here, which is the first statement in this program? The first statement is sum equal to 0. The initialization is happening. So we will so some initialization statement happens. That means it has completed some task. So we will be incrementing the value of count as count equals to 1. So you have to write like this: count equals to count plus 1. Okay, like that, count plus 1. Clear? So this count is for whom? This count is for this sum value. It is for what? I am writing here as comment. Okay, this is for a sum. Clear? Now you come to your control come to this for loop. So for loop means what is happening in the for loop? Two things are happening. First, initialization statement is there. This is a conditional statement, and this is the incrementation statement. Okay, so three different type of statements are there inside the for format. Okay, so first initially these two statements gets executed. First I equal to 0 happens, and it will check with the value. Condition checking happens. Okay, so two actions are performed there. So when you are entering into the for loop, two actions are performed. So it requires some time. Okay, so you are going to increment the value for that. Count is equal to count plus 1. Okay. So for the entry of the for loop, these two actions are performed by default. Okay. Anyhow, two actions are performed. You have to increment the count value by 1 only. Okay. So I'm writing the comment statement like this. Comment is what? This is for a for entry. This count is for what? A for entry or for loop entry. Clear? Now, after that, what is happening? After this, some incrementation is happening. Sum is equals to sum plus a of I. So that summation is happening. And you know how this for loop works. Okay. So since this statement executed, so you are incrementing count is equals to count plus 1. count is equals to count plus 1. Okay. This is for what? This is for the sum calculation. Clear? I will write it here as the comment. This count is for a sum calculation. Sum calculation. Okay. And after this, what happens? Again, this for loop will run for n number of times, and you know at what time it is going to exit. So next time what happens after the calculation of sum, this for control will come again to this for statement. I value is incremented, and then this I value is checked with n, and again if that condition is true, it will enter into the for loop. Likewise, this for loop will execute n number of times. Okay, and when it is going to exit from the for loop, when the I value becomes greater than n. Okay, when the value of I becomes greater than n, then only your this for loop exiting happens. So that means to exit from the for loop, that extra condition checking happens. Okay, the value of I incremented, and it reaches a value which is greater than n. So how you are getting that point? How you understand that the I value, how the system understand that the I value has reached a value which is greater than n? By doing this checking, isn't it? By doing this checking. So that extra checking is happening. So some amount of time is spent. For that purpose, for exiting from the for loop, there is some amount of time spent, and that is indicated by this count. Okay, so the count which is outside the for loop is for for loop exiting. So I will be writing that in comment statements. It is for loop exiting. Okay, so that means when you are entering into a loop, you require some amount of for entry, and also when you are exiting from a loop, you require some amount of time. Okay, so hope you understood the meaning why you require amount of time for the exiting of a loop and for the entry of the loop. Okay, after that what happens? This sum return, sum, whatever value is stored at the end of this sum, that is returned here. Okay, so this is returning the answer to the address from where this program has been called. Okay, so it is doing some action. So for that you are writing count is equals to count plus 1. Count is equals to count plus 1. Okay, so this count value is for what? This count value is for a returning sum value, for returning sum, for returning sum. Okay, hope this is clear. Now you have to calculate the total count. Then only you will get the total step counts, and that total step count gives you the program steps. That means the time complexity. So now you have to calculate. So initially what is the value of count? It was 0. So this count is equals to count plus 1. So your value 0 now is 1, incremented by 1. And now this is your for loop. This portion is for a for loop. This much is for loop. Inside the for loop, how many count is there? Inside the for loop, 2 count is there. Okay. So that means 2 times it has been incremented. The value of count is incremented 2 times. And you know how many times this incrementation of count happens twice inside the for loop? Do you know? Can you think how many times this incrementation of count twice happens inside the for loop? Yes, n number of times. Okay, since this for loop is going to execute n number of times, so inside the for loop, 2 count incrementation is there. So these 2 count incrementation will happen twice. Okay, twice times, twice of n numbers. Okay, 2. So total count incrementation inside the for loop is 2n. Okay, 2 into n times. Hope you got this. This 2 is for this counter, these two counter, and this n is for what? This n is for the complete, this for loop executes n times. So 2n times this count value will get incremented. Okay, and now outside the count there is only one incrementation. So you have to add all that now. So 1 plus inside the for loop you had 2n, and then outside the for loop how many count incrementation is there? This is the 1 and this is another 1. So 1 plus 1, 2. Okay, so total how many? So what will be the total time complexity of this program? It will be 2 plus 1, 3. That means 2n plus 3. 2n plus 3. So this is the time complexity, and this time complexity is indicated by small t with program name. Okay, so TP. This TP is pointing to the instance characteristics. Okay, so we are focusing on to the instant characteristics here. So you know that here this program completely depends upon the value of n. Okay, so whatever be the value of n, this program will take that amount of time, you know. So complete the time of this program depends upon the value of n. When the number of elements you provide for addition is 5, so what you will get? 5 into 2, 10, 10 plus 3, 13. That means suppose you are measuring the time in milliseconds, so 13 millisecond will be the total amount of time needed for this program. And suppose you are providing n equal to 100, so what will be the time? 100 into 2, 200, 200 plus 3, 203 milliseconds. So see, this variation is happening only because of this n value. Okay, only because of this n value. And this n value is the instance characteristic of this program. So TP, your TP is equals to 2n plus 3. So time complexity is indicated by the term TP. Okay, small letter t and small letter p. So instead of p, this is p means time complexity of program. So you can write like this. For our program, what is the name of our program? It was add. So you can write like this, t of add. Okay, t with subscript add is equal to 2n plus 3. So this is how the time complexity is calculated using the global variable count. Okay. Hope I made you clear about the way how the time complexity is being calculated using the global variable count. If you have any doubt, you can contact me in person. That means through my WhatsApp message, through you can send the messages privately in WhatsApp, or you can call me directly. Okay. So please watch this video again and again and try to understand the concept. Read the module that I have provided you, and come to me with some doubts. Okay. Okay. Thank you so much for watching the video.